We looked at contingency tables and stacked bar charts previously to decide if we have evidence that two categorical variables might be related. So let's look at another example like this. This is the data from a famous experiment done by Loftus and Palmer in 1974 called the Reconstruction of Automobile Destruction. You have to love their creativity with the title. In this test, they wanted to see if the language used in gathering eyewitness testimony could affect the memory of eyewitnesses. To begin, they had 150 students watch a film of an automobile accident. After watching the film, students were randomly separated into 3 groups. One group was asked about how fast were the cars going when they smashed into each other. Another group received the same question, except the verb was changed to hit instead of smashed into. A third group was a control and was not asked anything about the speed of the cars. A week later, the participants were asked if they remembered seeing any broken glass in the accident footage. Note, there wasn't any. You can see here that overall in the test, about 80% of students did not report seeing glass and 20% did. But what we are really interested in is if when we used a specific term to ask the students about the crash, if it affected their memories. So here you can see the results of the 3 conditions. Is there evidence that language was related to reports of seeing broken glass? Well, it does appear that the group that reported seeing glass the most frequently was the group that heard the phrase smashed into, while the rates of reporting seeing glass were fairly similar for the hit and control groups. But this visual check is not statistical evidence. To get that, we need to return to a new version of our chi-square test. This is the chi-square test of independence. In this test, we will be using the same formula we used for the goodness of fit test, which, if you remember, involves comparing observed counts to expected counts. Let's begin our test. First, we must establish our null and alternate hypothesis again. Here, our null hypothesis is that there is no relationship between our 2 variables, or that the variables are independent. If the variables are independent, that would mean that we expect to find we have similar rates of reporting seeing glass for each of the groups. However, if we find that the language they heard did cause differing reports of seeing glass, this is evidence of a relationship between the variables. That is our alternate hypothesis. Our conditions for this test are the same as our last test. To check our expected counts condition, now we will have to calculate them for this test. We will use what we expect to find if the null were true to calculate our expected counts. If the null were true, then we would expect to find that the 3 conditions have the same rate of reporting seeing glass. To calculate what we expect to see if the null were true, we have to do a little bit of algebra. We need to figure out what count we would expect to see first for the control group. To do this, we set up a proportion of x over 50 and set it equal to 29 over 150. X will be what we would expect if the rates of seeing glass were the same for all of the groups. When we solve, we end up with a shortcut that we can use to calculate the rest of the expected counts. We end up with row total times column total over grand total. Repeating this formula, we get all of our expected counts. Since we have equal group sizes, our expected counts repeat, but this isn't always the case. Our smallest expected count is 9.67, and since we have an expected count of at least 5 in all cells, we meet our condition. Now we can finish our test, comparing each observed and expected count. Our final test statistic is 7.78. The degrees of freedom for this test are calculated by taking the number of rows minus 1 and multiplying it by the number of columns minus 1. For this test, that is 3 rows minus 1 times 2 columns minus 1, or 2 degrees of freedom, which gives us a critical value of 5.99. You can see here our p-value is small, and since our chi-square statistic is larger than our critical as well, we find evidence that we can reject the null hypothesis. This tells us that we have evidence that there is a relationship between language used and memory of seeing glass, just like we thought from our initial chart. To take this a step further, we can calculate something called relative risk. This will let us know how much more likely students were to report seeing glass for those who heard smash than those who heard hit or were in the control group. To do this, we will first calculate the percentage of students who reported seeing glass in each group. Then we will divide these percentages to calculate a ratio. You can see from this that while the group that heard hit was only 1.17 times more likely to report seeing glass than the control, the group that heard smash was 2.29 times more likely to report seeing glass than the hit group, and 2.5 times more likely than the control. So we have evidence that hearing the term smash really did impact the students' memories.